So for this problem, to find the sum and the difference of these two vectors, so first we need to plot the graph of these two vectors. Then for vector A, so we have this west of south, so this is vector A, west of south. So we have this 42 degrees west of south, so therefore the given angle is in the south and this is 42 degrees. Then for vector B, east of north, then 77 degrees east of north, so therefore the given angle is in the north and that's 77 degrees. Then using now this table for the vector components, so we have this the given magnitude or the force. So for vector A, 123 Newton, vector B, that's 83 Newton. Then for theta, so take note that theta always starts from east. So to solve for angle theta for vector A, from east to vector A, and this one is 90 degrees, 180 degrees, 270 degrees, and 360 degrees. So observe that the given angle for vector A is outside the rotation, so therefore we need to subtract this 270 degrees minus 42 degrees. So therefore theta for vector A is 228 degrees. Then theta for vector B, so this is vector B and starts from east to vector B. Then observe that the given angle for vector B is also outside the rotation. Then we need to subtract this 90 degrees minus 77 degrees. So theta for vector B is 13 degrees. So observe that if the given angle is inside the rotation, then you need to add. But if outside the rotation, you need to subtract. Then this time to find now the x component for vector A from this formula. So we have the magnitude for vector A, that's 123 times cosine angle theta, that's 228. So the x component for vector A is negative 82.30. Then for the x component for vector B, so the magnitude is 83, then cosine theta, that's 13 or 13 degrees. So the x component for vector B, that's 80.87. Then for the y component for vector A and vector B, using this formula, so we have 123, then sine angle theta, that's 228. So the y component for vector A, that's negative 91.41. Then for the y component for vector B, so we have 83, then sine 13 degrees. So this is positive 18.67. Then we need to find the summation of the x components. So we just need to add these two numbers. So we have negative 82.30 in plus 80.87. So that's negative 1.43. Then for the summation of the y components, so just add these two numbers and we have negative 91.41, then plus 18.67. So we have negative 72.74. Then using now these values, so we can find now the resultant force for the sum of these two vectors. So to find the resultant force, so we have the summation of x component, that's negative 1.43 to the power 2, then plus the summation of y component, so that's negative 72.74 to the power 2. Then to solve now for the resultant force, so since this one is negative, so we need to put inside the parentheses, then 1.43 close parentheses, then to the power 2, then plus, so open parentheses, then negative 72.74 close parentheses to the power 2. So we have this positive 5,293.15. Then take the square root to find the resultant force. So we have the square root of 5,293.15. So the resultant force is 72.75 Newton. Then to solve now for the angle, so using this formula, so we have the inverse tangent of the summation of y minus the summation of x. Then substitute now the values. So for the summation of y, that's negative 72.74, then over the summation of x, that's negative 1.41. So we have now theta equals, then for this inverse tangent, so we have shift, then tangent, negative 72.74 divided by negative 1.43, then close parentheses. So theta is equal to positive 88.87 degrees. Then to find out the direction of this resultant force, so using the x and the y components, so since the x component is negative, so this is negative x, and the y component is also negative, and this is negative y, so therefore the resultant force lies on this quadrant, and since theta is positive, so therefore counterclockwise, and this is now theta, so we have west and south, so therefore the resultant force is 72.75 Newton at 88.87 degrees south of west. So this is now the sum of these two vectors. Then to find the difference of this a minus b, since a minus b is equal to a plus the negative b, so therefore from b, this becomes negative b. So we just need to change the sign for the x component. Since this one is positive, so that becomes negative. And also from the y component, since this one is positive, so this also becomes negative. Then to find out the summation of the x and the y components, so we have negative 82.30, then plus negative 80.87, so negative 163.17. Then for the y component, so we have negative 91.41, then plus negative 18.67, so that's negative 110.08. Then for this angle theta, so from this given, and for this negative b, so the opposite direction for this positive b, so this is now the direction of negative b, and we have this 77 degrees. So again, starts from east to this vector negative b, and since this angle is outside the rotation, then you need to subtract this 270 degrees minus 77 degrees. So therefore the angle for negative b, or theta for negative b, that's 193 degrees. Then to solve now for the resultant force, so using this formula, so again, For the summation of x or the x component, so that's negative 163.17 to the power 2, then plus the square of the y component. Then to simplify, so since negative, so again put inside the parentheses, then 163.17 to the power 2, then plus the negative 110.08 to the power 2. So this is 38,742.06. Then take the square root to solve for the resultant force. So we have the square root of 38,742.06. So the resultant force is 196.83 Newton. Then to find the angle theta, so we have the inverse tangent for the summation of y, that's negative 110.08 over the summation of x, that's negative 163.17. So theta equals, so we have shift, then tangent, negative 110.08 divided by negative 163.17. So that's positive 34 degrees. Then to find the direction, so for summation of x, that's negative, and summation of y also negative. So the resultant force lies on this quadrant. Since this one is positive, so we have this counterclockwise. So this is now the location for angle theta, and this is west and south. So the resultant force for the difference of A minus B, so that's 196.83 Newton at 34 degrees south of west. Then for the difference of this B minus A, or this is equal to B plus negative A, so A now becomes negative, so we need to change the opposite sign for the x component for vector negative A. So this negative 82.30 becomes positive 82.30. This negative 91.40 becomes positive 91.41. Then to find now the summation of the x and the y components, so add these two numbers. So this is 163.17, and for the y, that's 110.08. Then for the angle for negative A, so for negative A, the opposite of vector A, so this is now for negative A, and this is 42 degrees. Then from east to vector negative A, since outside, so you subtract. So therefore, theta for negative A is 48 degrees. Then this time, to find out the resultant force, so this is 163.17 to the power 2 plus 110.08 to the power 2, or the resultant force is 38,742.06. Then take the square root, so that's 196.83 Newton. Then also for theta, so this is 110.08 divided by 163.17. So theta is also equal to 34 degrees. Then to find out the direction, since x is positive, so this is positive x, and y is also positive, so the resultant force lies on this quadrant, and this one is positive, so counterclockwise. So this is now theta, and this one is east and north. So therefore, the resultant force for A minus B is 196.83 Newton at 34 degrees north of east.